Maybe if I turn points on, I might be able to fudge this so that it looks like it. There we go. So, for example, this drill bit is 4.76 mil wide. It can't get into this part here because the curvature is too tight. So what I did was, and again, that's there's the 4.76 there, and that pretty much tells me that there are 44 points, I think. Yep, where the along right here where the curvature is too tight, and on this side as well, because it needs to be. If we look at the image, it needs to be, this part needs to have that curvature, and that part needs to have the curvature as well. So yeah, that tells me that's a quick measurement there of the existing curvature, and then I come through and I sort of rebuild this curve with 20 points, and I come through and I cull out the start and the end like so. So I get rid of these because I want the start and the end of the curve to remain the same, and then I essentially move these along a vector, along the x and the y. Let's have a look. There you go. You can see that moving there, and that moving there as well. Oh, wrong one. Moving there as well. So okay, sorry, I opened the wrong file. I had to change that to be the Z. So there you can see it moving there and moving there. Great. And then that rebuilds the curve into that, which is very, it's not good at the moment. And then essentially what's happening is takes that curve and it runs the same analysis again. So it will divide it up into a bunch of points, and then cull the ones where the radius is smaller than 4.76, and then it'll tell me that there are 47 points where the radius is currently too small to be milled by that 4.76 millimeter in diameter router bit. And then down here I've also got so there's the original curve. Oh, sorry. There's the slightly rebuilt curve. Sorry, original. And then there's the completely rebuilt curve. Whoop, there it is. And then I've got like a series of difference curves. This is just a visualization that was like, that's where the original one is, and that's the new one. And then what I've also done is measured the total distance of these curves. So that's a goal as well that I want to minimize. So essentially, I want to draw this as the designer and go, yep, this curve is right because it allows the timber to fit neatly together, and it's kind of drawn along the stress lines. I want a result that's similar to that, right? So if I minimize this, it's going to be as close to the original curve as possible. And then I also want to have this goal of minimizing the amount of points along the new curve, along this curve, where the radius is less than 4.76. So I've got the X and the Z controls here that they're the main genomes. I've got this difference coming out as a number that I'm going to minimize, and you'll see that this is actually a positive number that is hooked into Octopus. So Octopus will always want to minimize things. Unless you put negative, it'll want to maximize it. And then over here is the same result, 47. Yeah, that we're going to minimize also. So in the next video, I'm going to start to run the optimization and show the interface. And before I go, remember to save your work constantly, and to smash that like button if you like this video. Thanks guys.